Alright, 8-7, horizontal above ground tanks, protected tanks. 871, general design consideration. Well, when small, 250 to 20,000 gallons above the ground storage of the tanks are required, there are clearance to fire exposure problems. The additional cost that can be justified concerning the use of the protected storage tanks. The main advantage of the protected tanks over a single wall steel tanks that ever are separated. The tank of the containment may not be required with the wall system, but the added dimension for the fire protection. The NFPA 30 and NPA 30A has specific criteria for emitting tanks when using the type of the secondary containment type of the tank. All of the criteria for the NFPA regulation for the appropriate application must be before the type of the tank is used. With the how to type additional benefits include the adding protection with the ballistic vehicular impact with reducing the vaporization, volatile fumes within water climates that require the tanks to be factory constructed with the UL142 oiled steel primary tank, generally to low profile rectangular design. Tanks may be used to applications where the in addition will develop the consideration construction of separate tanks for the secondary containment. The purpose for the negative impact on all operations. The anesthetic the tanks located with the clause buildings with integral fuel dispenser. Most of the UL listed secondary containment tanks utilize seal and inner and outer tanks can be the interstitial contaminate, which is both pressure and test and verifiable. Such tanks usually have a filled regulars insulating concrete to ensure the 2-hour fire rating meets the exceeding with all the requirements of the NFPA 30 with the fire resistant tanks meets the requirements of the UF3 601 provided with minimum 2-hour fire rating on the accordance with the UFC 601 UL 2085. 872 installation for the flammable liquid installation required additional carbon contaminated based on the tank of the filling raised to the zero. The chance of fuel and spilling entered in the critical area. Installing the tank so that the bottom slopes downward toward one end of the slope with the 1% located with the transfer pump. The suction pump at the high end of the tank located the water draw off at the low end of the tank. Provide water to draw off the lines of each of the tank. The aviation fuel system that arranged with the piping so that the fuel tank of the baby recirculated through the filter separate locate with the water draw off piping in the low end of the filter for the tank. For applications not requiring secondary containment such as residential heating oil tanks with the aesthetic may be for the prime concern with considering protecting explorated aggregated tanks of the UL 2085. The secondary containment protective rating without the outer steel jacket. A primary tank of the stainless steel can be allowed as an option to the interior coat of the carbon steel for all applications with the economically justified. F. Required support channels with the anchor holes with the earthquake, hurricane, and flood resistant tie downs. Requires a shield's minimum thickness of 3/16 of an inch for the interior carbon steel tank. Provide protective bollards in the traffic areas. Require the tank to be pressure tested after installation. Require the tanks to be inspected with the SCI registered and inspected with the level 1-2 class certification prior to the tanks being put into service. 8.8 above ground vertical storage tanks. The 8.81 general design consideration provided with the cylindrical single wall steel above ground vertical storage tank meeting one of the following criteria as approved by the Surface Headquarters Factory Fabricated tanks complying with the UL 142 criteria with the diameter of the tanks limited to transportation restriction. Although these tanks are fabricated with the size up to 50,000 gallons, they become quite tall due to the interior diameter limitation. Given special consideration height and diameter ratios to ensure the tank stability. The fill erected tanks not requiring an internal pan following the API standard 650 configuring as required with the UFC filled erected tanks complying with the Department of Defense standard design AW782427. The standard design includes the tank ranging for the capacity of 2,500 barrels through 100,000 barrels. The internal pan requires the adapting by the design team for the tanks larger than 100,000 barrels use the multiple column API standard 650 design. Requiring tanks to be inspected with the SCI inspected with the level 1-2 class certification by the AP standard 653 certified inspector where the applicable prior to the tanks being put out into service. 882, the tank roof. The tanks have an inner floating plans, the design roof in conformance with the Department of Defense standard, the AW7824-7, the A830 interior floating pans. Tank containing Class 1 flammable fuels, mission critical Class 2 combustible fuels such as JP8 should be equipped with the full contact aluminum honeycomb floating pan. Otherwise, other classes in Class 2 require the floating pan of the tank does not comply with the spacing and decking requirements of the USC. The tank storage mission critical Class 3 fuels such as JP5 and diesel fuel marine. If located in a hot desert climate, it also requires the floating pans to eliminate in the fuel air interface a single slotted sealing well and penetrate the floating pan with the maximum diameter of 10 inches that is used for the automatic tank gauge system, and if allowed to provide without the vapor sleeve elbow bellow. The slotted well used for the manual measurement shall be equipped with an improved floating plug. For cone and roof tanks, the floating pans provided with the roof ventilation inspection. The hatch of the fixed roof, the overflow of the port vents near the top of the shear shell near the device. The floating pan, which with air are sized by the manufacturer to evacuate the air gases underneath the pan, but the pan is on its support during the filling operation. Provide the grounding bonds between the floating pan and the shell as follows: 3 lengths of the air, 3/16-inch diameter stranded extra flexible stainless steel wire rope with each extending from the top of the floating pan to the other side of the fixed roof. Attached to the 2 wires near the tank of the peripheral, 1/880 degrees apart, with attached to the 3rd wire of the floating pan and the manhole cover. Securely connect the wires of the pan extending vertically to the tank roof. Ensure the wires are accessible for the inspection. Ensure the wires are long enough to accommodate the full travel of the pan. Locate the wires that miss all the interior tanks in the appurtenances and structure. Provide an anti-rotation cables in accordance with the Department of Defense standards design AW78-2427. For the cone roof tanks, the floating pans provided with the gauge of the sampling hatch in accordance with the Department of Defense standards design AW78-2427. Provided 36-inch diameter cover manhole in the floating of the pan. 884 tank bottoms. The slope of the tank bottoms downward in accordance with the Department of Defense standards AW78-2427. The slope of 5% of the required of the passage of the drainage and self-cleaning action for the tank and storage of aviation turbine fuels. After tank construction is completely performed, hydrostatic tests, a helium test may be included as an option. Before these tests, prior to the tank coating, conduct all the tests recommended by the AP standard 650. 885 foundation. Design tank foundations on basis of the soil exploration program, including preliminary exploration of the minimum detailed exploration testing, and if existing soil data is not available or inadequate for the UFC011 Analyze the result of the exploration program to determine the most practical but economical design to provide with the stable foundation of the tank. See the Department of Defense standards AW78-2427 to minimum use the following criteria with all the tank designs. Preventing external corrosion for the tank bottoms, locating the tanks above the general tank field grade, provided adequate tank field drainage away from the tank at the construction of the foundation pad with the cleaning, free draining granular material. If the sand is used, to ensure the minimum electrical resistance of 50,000 ohms cm. Foundation material should be neutral, alkaline, pH greater than 7, chloride concentration less than 300 ppms. A sulfated construction concentrate less than 150 ppms as specified by the Department of Defense design AW78-2427. The sand must be washed and the pH must be raised to meet the requirements, including the cathodic protection to prevent external corrosion of the tank bottoms. Do not use the oil in the sand under the tank. Do not use the dredge material or beach sand. Provide good drain under the tank. Provide a reinforced concrete ring wall foundation secondary containment located with the tank at the bottom, minimum 12 inches above the dike basin. Cover the area beneath the tanks with the dike fuel impermeable liner. Consider applying with the Department of Defense standards and AW78-2427 meeting the local state requirements, installing all liners according to the manufacturer's requirements over the liner and provided with a minimum of 12 inches above the compacted clean sand or similar material as described above. Securely attach the seal and seal the liner to the outside of the concrete foundation ring wall beneath the tank shell. Provide a leak detection system for the tank bottom and installing the pipes through the concrete founding the ring wall as the telltale for the tank of the bottom leaks according to the Department of Defense standards AW78-2427. These pipes will also permit the water beneath the tank to be escaped by gravity. Performance subsurface investigation in sufficient details will determine if any of the compressible, weak, organic, otherwise objectionable soil exists within the distance of 2 tank diameters below the ground surface. Estimate the magnitude rates of settlement on the uniform differential systematic induced as part of the design. Provide adequate flexibility to piping and prudency with other systems that accommodate the anticipated settlements. Accomplish the flexibility by using the pipes offsets with the ball joints. Do not use corrugated with the bellows with the type of expansion compensator. Do not exceed differential settlement valves given in the UFC 3220109 or 10N. Where other objectable materials exist, magnitudes that anticipated with the settlement are sufficient to cause the damage and conceptual distortion. Consider subsurface improvement. Potential improvement techniques may be included to remove the objectionable materials and replace them with clean, compacted granular fill, preloading, subcharging in the conjunction with the drainage, wicks, deep dynamic compaction, vibro compaction, stone columns, and compacting grouting, and the similar techniques. Alright, J, where justified with the subsurface condition, but the economics considered using deep foundations such as the driving piled and drilled shafts, designing foundation in accordance with the UF3-22011001N. Alright, 8-9 underground horizontal storage tank. General design consideration when underground storage tanks of up to 50,000 gallons less capacity are required for the use of factory built horizontal cylindrical double wall tanks, welded steel or fiberglass reinforced plastic. Ensure the contract requires the design installation in accordance with the Title 48 CFR Part 280 of the NFPA 30. Any more stringent state or local criteria require the separation of exterior tank the walls with the interior walls stand off, thus creating an open space interstitial for the monitoring of the leaks. It's called the Type 2 tank that does not exceed the 12 feet in diameter for the tanks. Limit the tank length of 8 times the diameter. Ensure the factory fabricated tanks comply with the UL58 and SDI P3 criteria. Installation. Install the tanks in accordance with the NFPA 30 with also the strict accordance with the manufacturing installation instructions. Install the tank so that the bottom of the slope downward toward one end of the slope with the 1%. Locate the transfer pump, the suction pumping, piping at the low end of the tank. Provide straps anchors designed to prevent the flotation of the tanks located in the areas of the high grounded water levels that are subjected to flooding. Provide electrical isolation strips that provide between the hold down straps in the metal of the tanks. Anchors which may be concreted anchor slab under the tank of the concrete dead man. Place tank vents in the uniform bed with a homogeneous granular material with at least 12 inches of thickness. Concrete anchor the slab is used to place a minimum 6 inches of the bedding of the steel tank from the 12 inches of the bedding of the fiberglass tanks between the tank and concrete anchor slab. Does not use the blocks or chocks or rocks. Ensure the tank is installed with the state certified contractor if the state has been certified for the program. Ensure that the tank is installed by a contractor that is certified by the tank manufacturer. Underground vertical storage tanks cut and cover. 810 general design consideration. Underground vertical storage tanks that are steel lined reinforced concrete with the leak of the monitoring capability. These tanks may be completely buried, surfacely constructed, and they convert over an embankment other than any variation in between the OCONA specific. They are only required to high threat areas when the tanks are required to be constructed within the explosive cordon area of the clear zone. Tanks being constructed with the OCONAS native with refer to the stagnant 3784 for the design guidance. They are not used in the CONAS except for where the tanks are required to be constructed with the explosive cordon design underground vertical steel torch tanks in accordance with the Department of Defense standard design AW782427 except as modified therein. These standards include the tank size of 10,000 to 100,000 barrels and capacity in general do not exceed 100,000 barrel capacity. Alternate design using the prefabricated pre-stressed tank section must be approved with the appropriate service of the headquarters. Provide leak detection for the underground storage tanks in accordance with the federal, state, and local regulations. Alright, 11. Prudencies. Table 1 describes the prudency for the atmospheric storage tanks with identify the type of the tank, which they should be mounted fuel seal welded all tank and attachments to prevent moisture and water for the corroding of the tank shell and attachments. 812 heaters. The general design consideration provided with the tank and the heat controls. The tank is intended for the storage of the high viscosity of the products, such as lube oils, burning fuels, number 4, number 5, number 6, in climates where the ambient tank temperature would be less than 20 degrees Fahrenheit above the fuel pour point and the temperature. The heavy burner fuels, oil, lube oils, the temperature 20 degrees Fahrenheit above the fuel's pour point prior to the pumping. Use only one of these type of the heaters listed below. 812 heating medium. Use an appropriate heating medium for the particular application based on the temperature, pressure, availability. Saturated steam is preferred with the heating of the medium, but considered using hot oil or hot water electrical heating whether the steam is not available for the existing source. 812 through the convention type of the heaters installed with the inside of the storage tank capable of passing through 36-inch diameter manhole for the capacity to raise the temperature of the full tank of the burner fuel oil to approximately 60 degrees Fahrenheit in its 24-hour service. The appropriate service headquarters of the DLA, DESC, with the determined capacity of the heaters could be reduced if not necessary to heat the fuel tank to full within 24 hours. 81211. In the type of line, the inline heaters consist of the two general types of tank sections of the straight tube. The analog line in heaters are shell and tubes construction. Tank suctions and suction inline heater with installed with the inside of the tank. On the tank issue line, the fuel oil enters the exchanger at the end of the tank exists with the opposite end of the outside of the tank. The seam of the overheating medium enters exists the exchanger at the end of the outside of the tank. The straight tube with the pipe inner line heater is installed directly into the pipeline. Fuel oil enters the exchange at one end of the and exists from the other. The entry and exist points for the steam side can be area. The following criteria applies in the inline heaters capable of overheating the fuel oil passing through the for the ambient tank at the temperature to minimum 20 degrees Fahrenheit. above the fuel oil's pour point temperature as required with the flow rate. If installed with the tanks, allow the removable heater tubes bundles without emptying the tank in multiple places. As inline heaters are used, do not allow the oil temperature to rise exceed 30 degrees Fahrenheit and 7 degrees Celsius per pass. Use the carbon steel shelf designed for the minimum of 170 psi gallons. It could work with the pressure on both steam and oil sides. Do not exceed 0.2 psi gallons for pressure drop on the oil side of the pump suction line, nor exceed 10 psi gallons for the pressure drop of the heaters installed with the pump discharge. Alright, 812.5. Installation and tracing. In case of where the fuels are heated, with examine the possible economic incentive to install the heating and storage of the vessel, the piping. In many cases, the piping carrying the heat of the product must be heated to trace the preventable possible solidification of the fuel during the shutdown period. Insulate trace lines with a considerable amount of possible incentives for installing a condensated collection for the return system. If condensated, the return system is installed with the include a monitor to detect the oil and the consideration. 813 underground storage tank spill contamination system. 831 general design consideration. Provided the drain structure to impound the escaping fuel with the rupture of an underground tank in a hillside location would endanger other activities and structures at elevators lower than the tank. Alright, 814 above ground tank spill contamination system. A general design consideration provided with the spill contamination system for all above ground tanks with the prevented with the spilled petroleum from leaving the property. The individual tanks larger than 10,000 barrels and the capacity should be enclosed in an individual dike enclosure. The roof of the tanks will no tank larger than 10,000 barrels, not exceeding the 15,000 barrels, and a graded capacity may be enclosed with a single dike enclosure subdivided each of the dike area containing the two or more tanks to be intermediate with the curbs. Prevent spills endangered adjacent tanks with the diked area. When subdividing is required, the unused intermediate curbs not less than 18 inches in height. Designer can take advantage of the exemption granted with the protective tanks by the NFPA 30 and FPA 30A. If the provision of the document are met in local states and the federal regulations permit, refer to the Department of Defense Standard AW782427 using the following criteria to tank spill contamination system. The preferred method of contamination is the dike enclosure to impound spilled fuel around the tank of the being means of the dike and preventing with the accidental discharge petroleum. As an alternate to the dike enclosure, use the remote impounded spill collection system consisting of a series of drains leading to the storage tank areas to remote contamination impoundment designed to prevent accidental discharge of petroleum. That this is not preferably method if it requires approval of service headquarters. Generally, this system is used for the tanks on the hillside. Slope the area with contamination not less than 1% of the area of the drain away from the tank to the sump located with the low point of the enclosure. Construct the drain line for the sump on petroleum resistant, fire resistant, impervious material. Do not use clay or concrete, fiberglass, or plastic piping materials. Control drainage for the sump at the outside of the enclosure. Provide the lockable knife gate with the valve with the indicator of the post located outside of the enclosure in the area that will be safely accessible during a fire. Do not allow any fuel to run off the escape of the contaminated area under any circumstances. Provide means of disposing of the oil or treating the contaminated water from the contaminant to meet the most stringent applicable federal, state, and local requirements. 8412 spill containment system capacity. Dikes enclosures. Design dikes enclosure in accordance with the most stringent NFPA 30 and the 40 Title 43 Part 112 with other federal, state, and local regulations. Additionally, ensure that the capacity of the dike enclosure is a minimum greater than the largest tank volume located within the dike enclosure, plus the sufficient freeboard equal to the greater of the 24-hour, 25-year storm of 1 foot over the entire area of the drainage. In the event of the fire, the dike enclosure must be able to contain the flow of the water from the firefighting activities for 20 minutes. An appropriate environmental climates to consider snow and ice and accumulating, as well as light. Limited dike heights to 6 feet or less. Alright. 814.22 remote impounds. Improve service headquarters design remote impounds within accordance with the most stringent NFPA 3040 Title 40 CFR Part 112. Other federal, state, and local regulations. Additional ensure the capacity of the remote impounds is at a minimum greater than the largest tank of the volume located within the area of the drainage, plus the Sufficient freeboard equal to the greater of the 24 hours 25-year storm or 1 foot of the overall entire area of the drainage. When sizing the remote impound with the considered with the total drainage area to all tanks that are included in the spill collection system. In the event of the fire, the draining system impound must be able to contain the flow of the water from the firefighting activities for 20 minutes with the neighboring storage tanks, sharing the same spill collection system in appropriate environmental climates. Consider snow, ice, and accumulation as well. 814.3 The remote containment embodiment spill contaminant collection system. Construct the remote impound is generally described as for a dike enclosure as in accordance with the UFC011, UFC011. 814.4 The disclosed enclosure. Earthen dike type. The construction either earthen dikes that are either the earthen material, fuel, impermeable liner covered where the space is premier. Constructed dikes, vertical concrete wall. Either the dikes may be minimum distance from the toe of the dike to the tank of the foundation 5 feet, and the provided with a flat surface on the top of the dike at least 3 feet wide. Do not make earth dike slopes deeper than 1 vertical to 1.5 horizontal. Cover the sides and the top of the earthen dike with the floor around the tank within one of the following materials. See facility plate 09. A fuel impermeable liner. If the liner is exposed with exposed areas, may be resistant with the effects of the direct sunlight to be wind to uplift. Provided with the sandbags in accordance with the appropriate UFGS to assure the liner is resistant to the wind uplift. Following the liner's manufacturer recommendation for the protection liner for the use of the geotextile cover for the other recommendation means provide a concrete maintenance pad for the personal access for the tank for the work areas and around the tank manholes and valves. Do not use benzotype and benzotype composite material in the construction of dikes or basins. Do not use asphalt. 814.5 Dike enclosure reinforced concrete dike types. Design reinforced concrete fabricated cast in place dikes. These are foundation resist contained with a full hydrostatic load when filled with capacity. Consider the use of the reinforced concrete blocks with either exterior with either mounting. Use vertical reinforced concrete dikes where the spice is a premium. Seal the concrete surface with a flexible UV resistant fuel resistant coating is required by the state law or regulations using the fuel impermeable liner as described above for the dike floor. 814.6 The dike enclosure combination dike type. The vertical concrete walled back to the external earthen berm may be used in the design of the combined earthen concrete unit and is the foundation of resist the containing of the full hydrostatic load blend filled with capacity. Use the fuel impermeable liner as described and above this dike floor. 8417 Stormwater Collection System. Design the stormwater collection system containing the transportation treat discharge any of the stormwater that collects the tank enclosure. Further, the chapter 2 of the U.S. facility criteria, the review of the state and local regulations, design requirements for the stormwater treatment system. Alright, 814.8 Dike access. Provided with the concrete steel aluminum steps with the pipe handrails for the passage across the dike step of the handrails must comply with the Title 29 CFR Part 1 1910. Title 29 CFR Part 1910-36, including removable section of the handrail to provide access to the flat top of the earthen dikes, and if the steel steps are used, they should be hot dipped and galvanized after fabrication and provided enough access location for the safe emergency egress for the normal operation. This will normally include steps over the dike separating the adjacent tanks as well as one of the wall without adjacent tank located in step at the most accessible points, preferably on the same side of the access of the stairs to the tank of the roof. For the tanks over the 10,000 barrels, larger considered provided the earth-filled ramps to permit the vehicle access into the dike when approved by the services of headquarters. There is insufficient need to provide vehicle access into the dikes and provided with a concrete paved road or either earth-filled ramp for vehicle travelways or removable steel bulkhead section may be cost-effective method to provide access to dikes. Vertical reinforced concrete walls with the vehicle access the road across the dike is provided with a security gate with a prominent sign indicating the access limited to 1-ton pickup truck that is compliant with the NFPA 70 Class 1 Group D Division 2 criteria. Alright, 815 Miscellaneous Use Tanks. The paragraph provides design guidance for the smallest miscellaneous use tanks. These tanks are typically less than 550 gallons in capacity. Check state and local regulations before beginning design. In miscellaneous use, the tank of the capacity greater than 12,000 gallons. Follow the requirements of Table 8.1, otherwise use the standard described below. 815.1 Installation. Install the tank in conformance with requirements of the NFPA 30. The exemption used for the deletion of the tank containment with acceptable if all the criteria associated with the exemption are met. Provide contamination for all the tanks regardless of the size except for the small residential heating and oil tanks before it by complying with the paragraph 814 of the UFC by using properly installed above ground concrete encased tanks in accordance with the paragraph 8.7 of the chapter of this UFC. 815.2 heating oil tanks comply with the NFPA 31. E815.3 emergency generator fuel tanks comply with NFPA 31, NFPA 37, and FPA 110. 815.4 fire pump fuel tanks comply with the FPA 20 to FPA 20. 30, FPA 31, 815.5 waste oil tanks. Check the local state environmental regulation for additional requirements for storage of the waste oil. 815.16 contamination. Discussed previously in the chapter, provide with the containment under and around all the above ground tank, except for the home heating of the oil tanks. 815.7 the underground tanks ensure all underground tanks are double walled and have overfill protection as is described previously in this chapter. Alright, 816 ship off-board fuel storage tanks. 816.11 the function additional regular storage consider the storage tank if the fuel removed from the ship that may be off the specification otherwise not satisfactory for the intended use. The fuel may be downgraded to heating oil or diesel fuel marine. 816.12 general design consideration determine the volume requirements for the contaminated fuel storage tank by an activity to serve provided at the bottom of the loading of the facility of the tank of the trucking, loading, and offloading of the contaminated fuel. 816.3 locating with the contaminated fuel storage in the near of the facility tank of the form clearly with the mark of the tank. This is the type of the grade of the fuel. 817 the jet engine testing cell for the fuel storage tanks. Design jet engine testing cell fuel storage issue a system of the same standards as the operating storage tank of the fuel system. High level alarms, gauging and shutoffs, etc. Normal tanks are refilled with the using station aircraft refueling trucks through the aircraft single point refueling adapters. 818 fuel automated system, the Defense Logistics Agency Business System Modernization BSM Enterprise Resource Programs. The fuel section automated with the information system and designed for the support of the Defense Energy Support Supply Center of the Military Service and perform with the responsibility fuel management distribution, or AFS, is multiple function of the automated information system. Which provides the point of sale data, the collection, inventory control, finance, accounting, procurement, facility management, the BSM, ERP, business system, admin modernization, ERP composed of an integrated of commercial off-the-shelf software application based around the Oracle Relationship Database Management System, which is hosted on the commercial available computer hardware. The system will provide the interface with the existing logistic financing of the automated information system to be used only with the directive of the DLA and the Defense Energy Supply Center. 8.1 table of appurtenances, manhole, ladder stairs, level alarms, vents, gauge hitching and stilling wells, pipe connection, overfilling protection, water draw off, ball joints, cable support, striker plates, monitoring floor. Chapter 9 piping systems.